Alright, today's 8th grade lesson is on the area of a parallelogram, and this is actually pretty simple, but we are going to introduce one kind of new thing at the end where we actually combine some ideas and put all that together. So we're going to start with what the area of a parallelogram is, and then move into something a little bit more challenging. But more importantly, beyond this, it'll help us later on with some of the other things that we're going to deal with in the future. So first let's kind of dive into this, and we want to recall, because this will build us up to the parallelogram. To find the area of a rectangle, we multiply the length and the width, which are the perpendicular dimensions of a rectangle. Perpendicular means they come to a right angle with each other. So to figure out the volume of this, it would be x times y, which I have right here, or length times width. Also recall that to find the area of a triangle, we multiply the perpendicular base and height as the first step, calculating the area. Then we find half of that product. So that was base times height, and height was the perpendicular or the right angle height, altitude. And we multiply base times height, and then take half of that because triangles take up half of rectangles. Alright? And we're going to see that this relates to the area of a parallelogram. We still want to multiply by the height at a 90-degree angle. So it'll be a straight line up and down between the base and the top. And what we should see is that it's basically a rectangle, but it's shifted or slanted. Alright? The height stays the same. What we can do is think about it like this. If I took, so here's our parallelogram. If I took this piece right here, the triangle, and I took this and cut it off and put it over here, and we cut this off, we would have just a rectangle. Alright? So the whole idea behind that is that to find the area of a parallelogram, it's no different than finding the area of a rectangle. We call it length times width for a rectangle, but it could be base times height, same thing. So it's in two dimensions anyway. So base times height for the area of a parallelogram. And remember, the base is the straight up and down 90-degree angle to the base, which will come into play here. So it says find the perimeter and area. We're just going to focus on, well, we can find the perimeter too, why not? Let's do perimeter first, just to get that out of the way. Parallelograms, as we know, opposite sides are the same. So if this is 8, this is also 8. If this is 6, this is 6. So we can add 8 and 8 plus 6 plus 6. So this is perimeter. And 8 plus 8 is 16 plus 12. And we should get 28 centimeters perimeter. Alright? Now for area, we're going to do base times height. And what they're going to do is they're going to throw in this slanted part right here. That is not our height, remember. Our height makes a 90-degree angle with the base. So our base is 8, our height is 5. 8 times 5, and this is going to be 40, and it's going to be centimeters squared because we're talking area. Alright, so that's a very basic area of a parallelogram problem. What might happen in the future, in fact I know it will happen in the future, is they might not give you the height, and what you would have to do is use this slanted part to help you find the height. And that's a little more, well, we can definitely do that. We're not there yet, but we will get there, and once we do, I'll definitely show you how to do that. But sometimes that slanted portion or the side comes in handy, but in this case it didn't matter because they gave us the height. So just realize that, and that part will come when we get to it. But for now, don't worry about it. And main thing I wanted to show us today was this problem, or this type of problem. Excuse me for a second. Looks very lengthy. Not too difficult, but it takes a little bit of thinking, as most things do. Letter A says, on a coordinate plane, sketch and find the area of a parallelogram ABCD with vertices right there. So we have vertices, which are points. So here we have 2, 1. So let's graph that. Over 2, 1, 2, up 1, right there. B, 1, over 1, down 1, over 1, down 1, 1, negative 1, right there. Negative 2, negative 1, 1, 2, down 1. So back 2, down 1. And D, back 1, up 1, right here. And we should get a parallelogram looking shape. My lines will not be perfect. But there we go. We should have a parallelogram there. They want us to find the area of that. So this will be the darker one here. Area equals base times height. What is our base? Well, we count. 1, 2, 3. We have 3 units there. Times our height, which is 1, 2 units. So our area for this one is 6 units squared. That goes up to, that's letter A. Now B is where some things come into play that we've talked about before, but we haven't seen it for a little bit. It says graph the dilation of a parallelogram ABCD with a scale factor 3. Now dilation, that means we're going to make something bigger, kind of like dilating the pupils that we've talked about before. And we're going to do that with a scale factor of 3. All that means is we're going to take 3 and multiply it by each point. For instance, 2 times 3 is 6. 1 times 3 is 3. So one of our points is 6, 3. 1 times 3 is 3. Negative 1 times 3 is negative 3. 3 times negative 2 is negative 6. 3 times negative 1 is negative 3. And then our last point, negative 1 times 3 is negative 3. 1 times 3 is 3. So we're going to graph those points now. And we should get a parallelogram, but a bigger one. So that is over 6 up 3. 1, 2, 3, 4, 5, 6. 1, 2, 3. We have a point there. This is over 3 down 3. 1, 2, 3. 1, 2, 3. Negative 6, negative 3. That's back 6. 1, 2, 3, 4, 5, 6. Down 3. 1, 2, 3. Hopefully we can see those points. I'll check in a second. And then we have negative 3 up 3. 1, 2, 3. 1, 2, 3. So we should get a parallelogram, but a bigger one. Alright, I want to make sure we can see that. Alright, looks pretty good. Except for my line right here. Doesn't look very good there. So I'll fix that quick. And that should be a little better. Alright, so we should see that we have a very similar, this was a 2. Okay. We have a similar shape. These are in fact similar. That means the angles are all the same and the sides are proportional. Okay? So we should see that once we count out and figure out the area of this one with our base and our height. Okay? So let's figure out our base first. This is 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going to write that up here. So we have 9. So area for this one, base times height, equals 9 times whatever our height is, which is, I'll put it over here, 1, 2, 3, 4, 5, 6. So here's our height, which is 6. So we should notice that proportional wise, 2 to 6 is 3 times 3. 3 to 9 is times 3. So we've made each dimension bigger by 3, or 3 times as big, which makes sense because that was our scale factor. Alright, so our height is 6. And this is 54, 9 times 6, units squared. So there is our B, 54 units squared. Now C is where everything comes into play here. The area of the image is how many times the area of the first parallelogram that we drew. So we're comparing areas here. The sides ended up being 3 times bigger, but the area, 54 divided by 6 is 9. The area is 9 times bigger. So 9 times bigger there. Now why is it 9 times bigger? Well, remember with area we work in square units, okay? We changed this side by 3, and we also changed the height by 3. That's 2 dimensions that we changed by 3. So that is to say 3 to the second power square units, that is 9. So really, we don't have to go through and do A and B if they're asking just this question or just this question. If the scale factor is 3 and they want to know how many times bigger the area is, if they're talking area, that's square units. So just square your scale factor and you get how many times bigger the area would be. However, you might need to graph these to figure out individual areas, which they did want for A and B. Alright? So, do you have to remember that this will be the case, depending on your scale factor, in that you can square it? No, you don't have to remember that because you can always resort to what we did. It's a little longer, it doesn't take too long though, and it gets into the answer still. So this was the newer stuff that I wanted to point out today. And like I said, we'll be getting into some more difficult stuff as we go. Alright, thanks.